Earth, a tiny blue dot, the starting point of everything. But Cassini reminded us that our story doesn't end here. It expands outward toward Saturn, its moons, and the uncharted realms beyond. At Infinity Beyond, we believe that every great mission must inspire the next, and Cassini's legacy is already shaping the future of space exploration. First in line, Dragonfly. Scheduled to launch in the mid-2030s, Dragonfly is a revolutionary rotorcraft designed to fly on Titan, Saturn's largest moon. Powered by a radioisotope thermoelectric generator, it will hop between locations on Titan's icy, methane-rich surface, analyzing organic chemistry and potentially prebiotic conditions. Dragonfly will do what Cassini couldn't: explore Titan up close, as a robotic drone. Next, scientists are pushing for a dedicated Enceladus mission, one that could orbit or even land and analyze the plumes erupting from its south pole. Imagine a spacecraft sampling water directly from an alien ocean, searching for biosignatures, amino acids, or even microbial life. This could be one of the greatest discoveries in human history. Other mission proposals include Ice Giants probes. NASA and ESA are planning future missions to Uranus and Neptune, building upon the outer solar system knowledge that Cassini helped spark. Ring observatories. Ideas are being considered to send small spacecraft into the ring systems of Saturn, up close, to study their microstructure and evolution. Cassini also laid the groundwork for a new wave of planetary system studies. Its gravitational data reshaped our models of planetary interiors. Its imagery set a new standard for mission visuals. Its orbital mechanics inspired how we think about long-duration probes. And let's not forget the influence on exoplanet research. By studying Saturn's moons and ring system, we're better equipped to interpret data from distant planets and potential exomoons. The next Cassini may not look the same. It might not orbit Saturn. It might not even come from NASA. It could be an international collaboration, a private sector venture, or even a robotic fleet. But whatever form it takes, it will carry Cassini's spirit: daring, precision, and the pursuit of the unknown. And it's not just about Saturn. Cassini taught us to think bigger. It taught us to value persistence, patience, and poetic ambition in space science. The mission wasn't just about where we went, it was about how far we're willing to go. As we stand on the shoulders of Cassini, the next steps will take us to new worlds, new questions, and maybe, finally, new life. Coming next in Segment 9, Why Saturn Still Matters. Philosophical reflections from the edge of the solar system. Planet and some of its moons, Cassini was getting closer to Saturn and its rings than ever before. Beginning on November 30th, 2016, the probe initiated a series of high-risk maneuvers. It climbed above Saturn's North Pole and then plunged to a point just outside the narrow F ring, the fragile edge of Saturn's main rings. Cassini completed this maneuver 20 times, each orbit more daring than the last. But that wasn't the true climax. On April 22, 2017, Cassini leaped over the rings for the final time to begin its ultimate mission phase, the grand finale. This series of heart-pounding dives would take it between Saturn's innermost rings and the planet itself, territory no spacecraft had ever dared enter. These final 22 orbits, known as the proximal orbits, would bring Cassini within 1,600 kilometers of Saturn's cloud tops. The reason for this risky mission was clear. As stated by NASA, during the grand finale, Cassini would collect some of the most valuable information in the mission's history. These orbits allowed scientists to directly sample Saturn's upper atmosphere and inner magnetic field. Cassini became a diving sentinel, recording, transmitting, and sacrificing. Each loop pushed the spacecraft closer to potential destruction. Flying through areas previously thought to be filled with debris, engineers were shocked to find these zones relatively clear. But still, each dive was a gamble. The spacecraft's protective dish antenna was used as a shield against incoming particles. Cassini became a warrior of science. Its instruments pointed toward Saturn's secrets while it shielded itself from the unknown. It's during these final dives that Cassini made some of its most intimate observations, measuring the planet's gravitational field to determine the mass of its rings, capturing the whispers of the magnetic field, and diving into its atmosphere to analyze its composition directly. One of the most powerful revelations during this phase was the likely discovery that Saturn's rings are far younger than previously thought, perhaps only 100 million years old, born during the age of the dinosaurs on Earth. Cassini was not just observing, it was transforming our understanding of giant planets, planetary formation, and the conditions that may exist on distant exoplanets. And throughout it all, Cassini continued sending stunning visuals, shimmering auroras around Saturn's poles, swirling cloud formations, and moonlit shadows cast upon the rings. Every pass was a countdown. With each orbit, the spacecraft descended further, preparing for a final plunge into Saturn itself. It was a poetic ending, not one of failure, but one of noble purpose. On September 15, 2017, Cassini made its final descent. It entered Saturn's atmosphere at 70,000 miles per hour, its instruments beaming back data for as long as they could, until the spacecraft was incinerated by friction and pressure. This was no mere crash. It was a planned, heroic farewell, preserving the purity of moons like Enceladus and Titan for future exploration. As Infinity Beyond recounts this breathtaking finale, we're reminded that the cosmos is not just a place of darkness and cold, but a realm where machines carry humanity's dreams into the unknown, and sometimes give everything for the sake of discovery. Coming next in Segment 3, Titan and Enceladus, the moons that changed everything. When we talk about Cassini's legacy, we can't ignore what may be its most lasting gift: the imagery. Cassini wasn't just a scientific probe. It was an artist, painting with light, dust, and ice from 1 billion kilometers away. Among its most haunting images were the auroras, dancing around Saturn's poles, strange, ghostly lights unlike any on Earth. Though not fully understood, they're thought to be created by charged particles flowing from Saturn's rings and moons. These auroras generate enough heat to warm the upper atmosphere, and where hot and cold fronts meet, powerful winds are born. It is believed that these charged winds carry ions across Saturn's upper layers, creating currents that interfere with radiation readings. Some scientists even think these invisible winds are skewing measurements of Saturn's magnetic field, moving at different speeds than expected, creating their own mini-magnetic zones. Cassini didn't just capture beauty, it uncovered riddles. But let's take a moment now to explore the visual highlights, the moments that left Earth in awe. The Day the Earth Smiled, 2013. Cassini turned back toward Earth and captured a rare image of our home, a pale blue dot, suspended beneath Saturn's rings. For the first time, humanity posed for a photo 1.4 billion kilometers away. 2. Saturn eclipsing the Sun. Cassini positioned itself behind the planet and caught the sun backlighting the rings. The result? A celestial halo, a glowing Saturn silhouetted against the dark, an image that became an instant classic. 3. Titan's orange glow. Photographs of Titan's surface showed a dense haze lit by golden sunlight. Beneath that haze, a cold, dynamic world with methane lakes and alien shores. 4. Enceladus geysers. Cassini captured jets of ice and vapor bursting from Enceladus's south pole. These icy plumes, illuminated by the sun, sprayed kilometers into space, proof of a hidden ocean below. 5. Rings in detail. Never before had we seen Saturn's rings in such intricate resolution. Cassini showed us their gaps, waves, and microstructures, each shaped by moons, gravity, and time. Cassini's cameras weren't just tools, they were some windows into wonder. Every shot was calibrated not just to measure, but to inspire. These images became posters, museum displays, and desktop wallpapers. But more than that, they became evidence that our universe is not cold and lifeless, but majestic and full of potential. And Cassini's final image, just hours before plunging into Saturn, the spacecraft looked back one last time. It photographed the place it had studied for over a decade. The image was grainy, simple, yet deeply emotional. A goodbye not from machine to planet, but from humanity to its creation. At Infinity Beyond, we believe space isn't just about distance, it's about perspective. Cassini helped change ours. Up next in Segment 7, how Cassini changed humanity's place in the cosmos. Gravity, magnetosphere, its rings and its structure. Cassini kept gathering data right up until the last moment of its life, as it plunged into the mustard-colored clouds of Saturn's atmosphere and ultimately broke apart into thousands of tiny fragments. This final act wasn't just the end of a machine. It marked the culmination of one of the most ambitious space missions humanity has ever attempted. Couple that with the fact that Cassini provided some of the most jaw-dropping, awe-inspiring images of Saturn and the solar system ever recorded, and you have one incredible mission. I'm Alex Molan, and you're watching Infinity Beyond. Join me today as we embark on this Cassini supercut, retracing its grand finale, the period of time before the dive, what it discovered in its last moments, and how its data continues to inspire groundbreaking discoveries to this day. If you want to see Saturn's majestic beauty, there's no better way than through the eyes of Cassini. The first probe to reach Saturn was Pioneer 11 in 1979. That was when scientists confirmed that Saturn's largest moon, Titan, had a substantial atmosphere. But it was Cassini-Huygens that gave us the real tour. It traveled for nearly 7 years before reaching Saturn in 2004, after a slingshot trajectory that took it past Venus, Earth, and Jupiter. Cassini didn't just fly by, it became an orbiter. For over 13 years, it looped around Saturn 294 times, studying the planet, its rings, its magnetic field, and more than 60 of its moons. Alongside it, the Huygens probe separated and became the first and only lander to touch down on a moon in the outer solar system, Titan. In its journey, Cassini discovered geysers of water ice erupting from the moon Enceladus, indicating a subsurface ocean and the potential for microbial life. This tiny moon, once overlooked, became one of the prime targets in the search for extraterrestrial habitability. No other mission had ever hinted at such possibilities so far from the Sun. Cassini also gave us unprecedented detail on the structure of Saturn's rings. We learned they are made of billions of particles, ranging from micrometers to meters in size, each with its own orbit, forming waves, divisions, and patterns that dance to the rhythm of Saturn's gravity and its many moons. By the end of its mission, Cassini had orbited Saturn for over a decade, collected hundreds of thousands of images, and generated data that would become the foundation for more than 4,000 scientific research papers. Its legacy is monumental, not just in astronomy, but in our culture and imagination. And yet the mission was not just about science, it was about wonder. It was about that moment when we saw Saturn's hexagonal storm, perfectly symmetrical, spinning like a cosmic whirlpool. Or when we saw Earth as a pale blue dot through Saturn's rings, a haunting reminder of our fragility. But why end the mission by crashing Cassini into Saturn? The reason was simple: planetary protection. Cassini was running low on fuel. NASA feared that if it were left to drift, it might crash into a potentially life-bearing moon like Enceladus or Titan, contaminating it with Earth microbes. By guiding it into Saturn's atmosphere, they ensured a clean end, preserving the integrity of other worlds for future explorers. Infinity Beyond presents this saga not just as a series of scientific events, but as a testament to what humanity can achieve when we look up and dare to explore. Cassini didn't just send data, it sent back awe. Stay with us as we move into the second segment, The Dive. Cassini's final orbits. Below the gentle glow of Saturn's rings, the planet itself is shrouded in pitch blackness. As Cassini neared its final orbits, it captured breathtaking images of Saturn's atmosphere on September 12th. These were not ordinary photos. They focused on the planet's terminator line, the boundary between night and day. Because the sun was low on the horizon, massive cloud structures cast shadows that stretched for kilometers across Saturn's upper atmosphere. From a distance, you might think these were close-ups of weather systems on Earth, but this scene covered an area over 5,500 kilometers wide, large enough to fit Saturn's moon Titan several times over. On September 13th, Cassini performed one of its final flybys. In the images, you can see delicate ripples ahead of and behind some of Saturn's moons. These ripples occur because of differential orbital speeds between the rings and the moons. The inner rings orbit faster than the moon Dione, causing their waves to move ahead. The outer rings, moving slower, create trails that lag behind. These interactions are a window into the physics of orbital resonance. They showcase how gravity carves order into chaos, sculpting arcs, gaps, and braids into Saturn's ring system. From the Cassini division to the A-ring's rippling edges, every band tells a story of mass and motion. Cassini observed propellers in the rings, small disturbances caused by moonlets too tiny to be seen directly. These features, like signatures in ice, allowed astronomers to track invisible objects by their influence alone. It's celestial detective work at its finest. Then came one of the most iconic sights Cassini ever sent back: the planet backlit by the sun, with the rings shining like a halo. In this moment, Cassini also captured Earth, a distant pale blue dot suspended within the rings. The image is humbling, a cosmic selfie from a billion miles away. Saturn's rings are not solid. They are composed of countless particles, ranging in size from grains of sand to boulders the size of houses. Made primarily of water ice, they reflect sunlight brilliantly, giving Saturn its radiant appearance in telescopes. Cassini revealed that the rings are surprisingly young, perhaps only 100 to 200 million years old. This revelation challenged long-standing theories that dated them to the formation of the solar system. The rings might have formed when a moon or icy body ventured too close and was shredded by Saturn's gravity. Yet they are constantly changing. Micrometeoroid impacts darken the rings over time. The rings rain material onto the planet's atmosphere. Cassini measured this ring rain, which acts like a slow erosion process. The majestic rings we see today might one day vanish, but even as their future is uncertain, the rings remain one of the most elegant structures in the solar system, dancing to the silent music of gravity. On Infinity Beyond, we celebrate these wonders not only for their scientific value, but for their beauty and symbolism. The rings of Saturn remind us that the universe can be precise and poetic at once, harsh yet breathtaking. Next in Segment 5, the legacy of Cassini, what we learned and what comes next. With every discovery Cassini made, more questions emerged. One such mystery started with a deceptively simple query: how long is a day on Saturn? Despite thousands of years of observing Saturn in the sky, Scientists didn't have a clear answer. Unlike rocky planets, where surface features can be tracked, Saturn's thick layers of clouds obscure any solid core. These clouds rotate at different speeds depending on latitude, making it impossible to pinpoint a clear rotation period using visual markers. And Saturn's rings? Though mesmerizing, they orbit at their own variable speeds, depending on proximity to the planet. Using ring motion as a clock doesn't help here either. Scientists turn to Saturn's magnetic field to try a different approach. Magnetic fields are typically tied to the planet's core and can act as a natural metronome. For Jupiter, this method worked perfectly. The planet's magnetic emissions revealed its true rotation. But Saturn's field is different, almost perfectly aligned with its axis, which makes measuring rotational variations extremely difficult. It was Cassini's final orbits, its grand finale, that gave scientists their best chance. As the probe dove between Saturn and its rings, it directly measured gravitational and magnetic field data with unprecedented precision. From this, researchers discovered another surprise. Saturn's core isn't a simple solid ball. It's a diffuse, fuzzy region, perhaps extending more than half the planet's radius, a mixture of rock, ice, and metallic hydrogen. This blurred boundary challenges long-held assumptions about gas giants and planetary formation. Cassini also helped revise the mass of Saturn's rings, revealing that they are lighter than expected. This supports the theory that they are geologically young, likely formed during the age of dinosaurs on Earth. And yet, the true length of a Saturn day? Still debated. Cassini brought us closer, but the final answer remains elusive. Cassini's instruments also peered into Saturn's seasonal shifts. Over 13 years, it observed summer in the southern hemisphere and winter in the north, then watched as seasons reversed. These long-term observations gave scientists their first real look at how a gas giant's climate changes over time. And the mission's reach extended beyond Saturn. By analyzing Titan's thick atmosphere and Enceladus's oceanic plumes, Cassini shifted the focus of astrobiology to these distant, icy worlds. The findings fundamentally changed NASA's priorities, helping inspire missions like Dragonfly, launching in the 2030s, which will send a rotorcraft to Titan to explore its surface. Proposed missions to Enceladus, with plans to orbit or land and directly sample material from its plumes. On Infinity Beyond, we look at Cassini not as a mission that ended, but as one that launched an era of discovery. Its data will be mined for decades. Its images will inspire generations. Its questions will guide the next wave of exploration. What Cassini taught us most is this: even in the final moments of a mission, there is room for discovery. Even in death, there is legacy. Up next in Segment 6, the most beautiful images from Cassini, a visual tour through time. The waves on Saturn's rings don't just look beautiful, they tell time. According to NASA, the distance between each wave crest can represent 4 years of propagation caused by gravitational interactions. In fact, by reading these patterns, scientists have reconstructed decades of orbital history of Saturn's moons, especially Janus and Epimetheus. This method is akin to reading tree rings, nature encoding time in elegant patterns. But the moons themselves hold even deeper secrets. Among Saturn's many satellites, 2 changed the course of planetary science forever: Titan and Enceladus. Let's begin with Titan. The second largest moon in the solar system. Larger than Mercury, Titan has a thick, nitrogen-rich atmosphere. It's the only moon we know of with a substantial atmosphere and/or liquid lakes. On its surface, not of water, but liquid methane and ethane. The Huygens probe, carried aboard Cassini, detached and descended onto Titan's surface in 2005. It parachuted through Titan's orange haze, capturing surreal photos and analyzing atmospheric composition along the way. When it landed, it transmitted data for over 72 minutes, the first and only landing on a world in the outer solar system. Titan looked eerily Earth-like. River channels, shoreline patterns, erosion. But it was alien. Freezing temperatures, hydrocarbon rain, and an orange sky. Scientists believe that Titan may mirror early Earth, offering clues to how life might have once started on our own planet, or how it could arise elsewhere. Next, Enceladus. Tiny ice-covered moon just 500 kilometers across. It was expected to be geologically dead. Cassini proved otherwise. In 2005, Cassini observed plumes of water vapor erupting from Enceladus's south pole. These geysers blasted through fractures known as tiger stripes. The implications were astonishing. A global subsurface ocean beneath its icy shell. Even more shocking, Cassini flew through the plumes and detected water, salts, organics, and hydrogen. Ingredients for life. Enceladus had gone from obscurity to becoming one of the most promising places in our solar system to search for alien life. Both Titan and Enceladus challenged our assumptions. Who would have thought that frozen moons could host liquid oceans or complex chemistry? That these worlds, orbiting far from the sun, could become frontiers in the search for life? Cassini continued studying them both. It mapped Titan's methane storms, watched its changing seasons, and captured reflections of sunlight glinting off its lakes. It flew by Enceladus repeatedly, analyzing its spray, measuring its gravity, and photographing its fractured surface. The discoveries rewrote textbooks and shifted priorities in planetary science. Future missions are now being planned to return to these worlds, including NASA's Dragonfly mission to Titan, which will send a flying drone to explore its diverse terrain. As we continue through this saga on Infinity Beyond, remember that Cassini didn't just orbit Saturn. It gave us a deeper understanding of what it means to be alive in the cosmos. It showed us that even in the far reaches of our solar system, oceans can hide beneath ice, atmospheres can glow orange, and mysteries can lie beneath every crater. Up next in Segment 4, Saturn's Rings, a symphony of ice and gravity. Saturn isn't just a planet. It's a paradox, a giant made of gas, yet wrapped in some of the most all-perfectly ordered structures in the solar system. It's chaotic in nature, but serene in appearance. It's distant, but deeply familiar. At its North Pole, Saturn holds one of the strangest features in the solar system, a perfect hexagon. This massive jet stream, larger than Earth itself, forms a six-sided polygon that has lasted for decades, possibly centuries. Scientists theorize it's caused by wave patterns in atmospheric flow, but no other planet has anything like it. Toward the center of this storm lies an eye wall, calm yet deep. It's almost poetic, chaos giving rise to symmetry, storms creating structure. Saturn, in a way, is the yin and yang of the solar system. Then there's the magnetosphere. While not as powerful as Jupiter's, Saturn's magnetic field is still immense, stretching far beyond the planet and shielding it from the solar wind. Just like Earth, this field creates auroras, mystical lights that dance around the poles, glowing green and purple in Saturn's upper atmosphere. These auroras form when solar wind electrons spiral along magnetic field lines, smashing into molecules in the upper atmosphere. They glow not just with light, but with meaning. They show us that Saturn is alive, reactive, and expressive. But perhaps Saturn's greatest philosophical lesson lies in its rings. They are thin, sometimes only tens of meters thick, but they stretch over 280,000 kilometers wide. Made of fragile ice and dust, they float in graceful, synchronous motion. No solid surface, no permanent form, just billions of pieces orbiting in a vast ballet. Saturn's rings remind us that beauty does not require permanence, and complexity can arise from simplicity. And yet, those rings are temporary. Cassini showed us they are young, possibly born just 100 million years ago, and that they are slowly falling into Saturn, grain by grain. The most iconic feature of the planet is also its most fleeting. Maybe that's the deeper message Saturn holds for us, that even the most magnificent things can be temporary. That balance is dynamic, not fixed. That the universe doesn't just produce order, it cycles through it, renews it, and lets it fade. On Infinity Beyond, we don't just ask what planets are made of, we ask what they mean. Saturn means symmetry, impermanence, duality, and mystery. It's both a teacher and a mirror, reflecting the delicate systems we see on Earth and the hidden ones inside ourselves. Coming next in Segment 10, Final Reflections, what Cassini and Saturn taught us about ourselves. Cassini didn't just teach us about Saturn, it taught us about ourselves. One of its lesser-known but most profound contributions came through sound. As the spacecraft passed into and out of Saturn's magnetosphere, it recorded the change in whole radio waves, from silence in interplanetary space to bursts of signals as it crossed the bow shock, where the solar wind meets Saturn's magnetic field. The result? An eerie, otherworldly soundtrack. You could now hear Saturn's magnetic heartbeat. And there was more. Cassini listened to lightning storms inside Saturn's clouds, massive electrical discharges unlike anything on Earth. These were not just measurements, they were experiences. They reminded us that space isn't empty, it's alive. But the most impactful legacy of Cassini wasn't scientific, it was philosophical. Cassini showed us the interconnectedness of everything. That rings can shape moons, that tiny geysers might reveal life, and that a machine built by human hands can orbit a planet 1 billion miles away for 13 years. It gave us the famous image of Earth through Saturn's rings, a tiny blue dot hanging in the vastness. That picture said more than any speech could. It whispered, "This is home," and it's small and precious. Cassini also redefined our relationship with machines. It wasn't just a robot, it was an ambassador, a scout, and in its final moments, a martyr, sacrificing itself to protect worlds it had never touched. At Infinity Beyond, we believe missions like Cassini recenter the human story. They remind us that we are not the masters of the cosmos, but participants in its grand design. When Cassini dove into Saturn's atmosphere, it wasn't just the end of a spacecraft, it was a ritual of knowledge, a poetic act that said, "We came, we saw, we understood, and now we return to the stars." The story of Cassini is now a part of our story. It lives in classrooms, in images, in data still being studied, and in the hearts of those who dare to dream beyond Earth. Coming next in Segment 8, what's next after Cassini? The future of exploring the outer solar system.